Okay, this is 7.7, calculating angles. So we have a transversal that passes through a rectangle. We know that this line is parallel to this line, so we want to name two corresponding angles. So corresponding means they're on the same side of the transversal, okay? But they're on the same side as the parallel line, so we can say that the corresponding angles would be angle A and angle C. Name two alternate exterior angles. Well, exterior means that they're on the outside of the line, so, and they're alternating, so we can say angle A and angle D. Angle A and angle D. Okay? Here's an example. Eddie cut some strips of flooring using two horizontal parallel cuts and one on an angle of 51 degrees. Okay, so we've got a floor. We have two parallel lines, angle D and D1 and D2. They are parallel to each other. How do we know? Because we see this symbol right here. We can also say that because the floor is parallel, that's also, those two lines are also parallel to these lines here, and we could also say that this outside line here is parallel to this line here. So basically what we have is we have a parallelogram. Okay, all we're given is this angle here, 51 degrees. Okay, but because these are parallel lines cut by transversal, they follow certain rules. Okay, so what is the measure of each angle? We can calculate the measure of angles 1 all the way up to 8 very simply, because we know that these are parallel cut by transversal. There's certain rules that apply. So it says angle 1 and angle 5 are 51 degrees. So that means that because that's 51 degrees, that means this is also 51 degrees and this is also 51 degrees. We know that when we've got two parallel lines cut by transversal, alternate angles are equal. So if that's 51 degrees, that also means that this is 51 degrees, angle 4, and that angle 8 is also 51 degrees. Okay, so right there we found 1, 2, 3, 4 angles very quickly. We know that a straight line forms 180 degrees. So we can find angle 2, 3, 6, and 7. They're all going to be equal as well. We take 180 degrees, we subtract 51 degrees, we get an answer of 129 degrees. So if that's 129 degrees, that means that this is 129 degrees because they're alternate angles, which means that this is 129 degrees and that this line here is 129 degrees. Okay, so all we needed was one angle, and we can calculate the other 7. Very simple. Okay, so you can write that down in here. Okay, another example. The design in a rectangular floor shows many parallel and perpendicular lines. Determine the measure of the angles. Explain your thinking. Okay, so we're given one angle, 60 degrees. So it says, what is the measure of the 8 acute angles, acute means less than 90, across the top of the diagram? So if this is 60, that means that this angle here is also 60. This is also 60, so it's that, and that. Okay, so they're all 60. How do we know? Because they're 60 degrees, because they're all parallel lines. Because the question tells us that it's parallel lines. Okay, so they're all 60 degrees. What is the measure of the 8 acute angles across the bottom? Well, this is 60 degrees. This line here is parallel to that line there. Okay, and if they're parallel, cut by this transversal right here, that means that this is also 60 degrees. Alternate interior angles are equal, which means that every single acute angle here, 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 and here are also 60 degrees. How do we know? Because alternate interior angles are equal. Okay, notice how I abbreviated here. What is the measure of the 7 obtuse angles across the bottom? Well, we know that this is a straight line. All straight lines add up to 180 degrees. So we just take 180, subtract 60. 180 degrees, subtract 60 degrees, and that gives us an answer of 120 degrees. How do we know? Because supplemental angles. Okay? And it also tells us that they're parallel lines cut by a transversal. Okay, so they follow certain rules. Okay, so that's it for calculating angles.